It can be hard to explain brain function, neuroplasticity, and the changes that happen in the brain in pain. And it's not an easy thing to tell somebody that pain is made in the brain. It's all a bit abstract. You can't see brain function. It's in 3D. But explaining pain and explaining the role of the brain in pain is a critical part of the Explain Pain work. These nail boxes may help. We all had one of these in the 70s. They're still around, easy to find, and they may well be making a comeback. Normally, we know our hands well. There's a lot of territory in the brain representing, looking after each hand. We can move each finger independently. We know where our hands and fingers are in space. You know when each finger is being touched, and we can do remarkable things with our hands. We can write, sculpt, play musical instruments, and talk. Let's say that each of these nails represents 1 million cells in the brain. And these will be cells that have neural and immune functions, and they work very closely together. We know our hands in the brain because these cells here representing each finger at a particular time and place can be turned on, and these ones in between turned off. The science term is inhibition. We also know that it changes dramatically. For example, if you have 2 fingers held together with a bit of tape, they will join up in the brain. Essentially, they become sticky. But within a few hours, with normal movement, this will reverse. Talk about use it or lose it, there's a lot of that in the brain. In pain, things are a little bit different. We know things can change dramatically. Let's say that the person's index and middle finger is in trouble, maybe in pain, not being used, frightened to move. What can happen if the brain makes the conclusion that more protection is needed? It can call upon neighbouring cells, neighbouring immune and neural cells, brotherhoods, sisterhoods, cousinhoods, neighbourhoods of cells, and pull them in to the territory looking after the fingers. So we call this smudging, or the science term is it becomes disinhibited. This remarkable defence might be helpful in the short term, but not so much in the long term. In the long term, you might not be able to recognise the difference between 2 fingers. It might feel a little bit different, not yours, a bit bigger, a bit smaller, perhaps. And you may start to see changes in activities, particularly high-level activities like playing a musical instrument, writing, doing up a button. These plasticity changes, of course, are not just confined to the hand. This can happen anywhere in the body. This sounds bad, but it's happening all the time. It happens in all of us. It's a very useful defence. The aim should be to get to know the hand again, to love the hand again, to re-embody the hand again. In a science sense, to take away or inhibit these cells in the middle which have joined on and become sticky with the original fingers. There's 3 main ways in which you do this. Principle E is education. If you can take away usually the fear that made the brain construct this defence, that would be number 1. Secondly, graded exposure, graded activity, which could range from thinking about movement to actually moving. And thirdly, taking the hand out into different contexts, feeling different surfaces, feeling different places, exploring with the hand in space. So here we have a very simple addition to the media of teaching. And one of the really good things about it is someone can actually do it themselves and feel what is going on. It actually feels quite nice too. Have a go yourself.